Hi everyone. In this video, we are going to learn how to use tree diagrams to organize information, find counts, and calculate probabilities. Let's get started. A tree diagram is a graph used to display all possible outcomes of an experiment. Each branch represents a possible outcome. The key idea is that a tree diagram helps us organize information visually, make it easier to count outcomes, and calculate probabilities. Tree diagrams are commonly used to organize outcomes, find probabilities, find counts, and display conditional situations. Notice that tree diagrams are especially useful when one category depends on another category. Let's work through example 1. A survey of 400 students asked whether they have a part-time job. We're given the following information. 55% are full-time students and 45% are part-time students. Among the full-time students, 80% have a part-time job and 20% do not have a part-time job. Among the part-time students, 30% have a part-time job and 70% do not have a part-time job. Before we answer any of the questions, let's build and complete a tree diagram. A common mistake is to jump directly into the calculations. Instead, it's usually easier to draw the entire tree first and then fill in the counts. We start with the total of 400 students. The first split in our tree is student status. One branch represents full-time students. The other branch represents part-time students. Since 55% of the students are full-time, we label the full-time branch with 55%. Since 45% of the students are part-time, we label the part-time branch with 45%. Now, let's extend each branch. Starting with the full-time branch, we are told that 80% have a part-time job and 20% do not have a part-time job. So from the full-time branch, we draw two additional branches. One branch is job, labeled 80%. The other branch is no job, labeled 20%. Next, we do the same thing for the part-time branch. One branch is job, labeled 30%, and the other branch is no job, labeled 70%. At this point, the structure of our tree diagram is complete. We have four possible outcomes: full-time and job, full-time and no job, part-time and job, part-time and no job. Now, let's calculate the count for each branch. We begin with the full-time branch. There are a total of 400 students. 55% are full-time. We take 400 times 0.55 equals 220. So there are 220 full-time students. Now, follow the full-time range to the job range. 80% of the full-time students have a part-time job. That is 80% of 220 have a part-time job. So we take 220 times 0.80 equals 176. So 176 full-time students have a part-time job. The remaining 20% of 220 do not have a job. So we take 220 times 0.02, which is 44. 44 full-time students do not have a part-time job. Now, let's move to the part-time range. 45% of 400 students are part-time. So we take 400 times 0.45 equals 180. There are 180 part-time students. 30% of 180 have a part-time job. So we take 180 times 0.3 equals 54. 54 part-time students have a part-time job. Oops, this should be 70% instead of 7%. So let's fix it. 70% of the part-time students do not have a part-time job. So we take 180 times 0.70 equals 126. 126 part-time students do not have a job. Now, our tree diagram is completely filled in. Before moving on, let's verify that we have accounted for all students. 176 plus 44 plus 54 plus 126 equals 400. Since the total matches the original survey size, our completed tree diagram is correct. Now that the tree diagram is complete, answering these questions becomes much easier because most of the information can be read directly from the diagram. Question A is asking for the number of full-time students. We can read that directly from the first branch. The answer is 220. Question B is asking for the number of part-time students. From the tree diagram, that is 180. Question C is asking for the number of full-time students who have part-time job. Full-time student and part-time job, 176. Question D is asking for the number of students who do have a part-time job. We need everyone in the job category. That includes 176 full-time students with jobs and 54 part-time students with jobs. So we take 176 plus 54. And that equals 230. Question E is asking for probability of selecting a full-time student who does not have a part-time job. So in this group of 400 students, I want to select one student, and that student has to be a full-time student and has no part-time job. From this tree diagram, the number of full-time students with no job is 44. So the probability is 44 over 400. And 44 divided by 400 is 0.11.